Welcome to yet another tutorial in our series of tutorials where we are learning R for data science. In this module, we are going to cover data types. So we're going to introduce what are data types. We're going to look at the various types of data types, including the logical, numeric, which include the double, the integer, the character, the complex, and factor data type. After that, we'll look for a data frame in R so that we can perform a basic conversion from one data type to another data type. So let's start. What is data types? Data types are forms in which different values or different variables are interpreted by our machines before they are being stored. So variables can store data of different types, and different types can do different things. So when entering data into R or performing data analysis, different types of data types can perform various types of analysis on different types of data types. So we start with logical or Boolean data type. This is the first data type, and it's the easiest, it's the simplest. The logical value, it can either take the value true or false, as the name suggests. Logic. So it's a Boolean variable whereby it can either take true or false, and they are mostly used to check for conditions. For example, here I'm saying x is equals to true. I'm assigning the value true to x. So let's run this and see. And here x is true. We want to see what's x, just type x, control enter, x, then run. We also define, or we also create a variable y. I can either use equals here, or I can use less and minus. This is how we assign a variable to our value. So here we are assigning y to the value false, and we run this. Then here, because I'm talking about logical or Boolean values, I want to see, I'm asking a question, is x equals to y? So here I'm using double equal signs. In the moment that if I use or if we use a single equal signs, it will be like we are assigning x to the variable, or we are assigning y to the variable x, which is not the case. See, I'm asking a question, is x actually equals to y? So when you are asking a question like, is this thing equals to this, we use double equal signs. I'm asking, is x equals to y? Let's see. It says it's false. It's false. So this data type that evaluates to either true or false are called logical. So we can use the type of, or this function called type of, and don't hesitate to use the help command. So type of let's run and see the help command. It tells me that type of determines the R internal type or storage mode of any object. So the type of help us in determining the type of data stored. So I'm asking the question, what's the type of x? And here it tells me that it is logical. So those any data type that evaluates to true or false, that is logical. In numerical interpretation, t evaluates to 1 and false evaluates to 0. For example, true plus true equals to 1, or true plus true equals to 2, because true evaluates to 1, and this true evaluates to 1, and also false evaluates to 0. I'm asking a question here. Is false equals to 0? This should be true. Let's run and see. There it is. It is true. So that is basically the logical data type. The second type of data type we are going to tackle is numeric. So numeric can either have a decimal or it can lack a decimal. So it can either be an integer, which is in a decimal, or it can be a double, which has doubles, or which has decimals. When you enter a numeric variable, for example 10 in R, it will be stored as numeric. That is, it will be stored as a double. Anytime you enter any data in R, it will be stored as numeric. So numerics are naturally doubles. For example, the value 10. The value 10 here, the value 10 is actually numeric. So if we type the type of 10, the type 10, it is a double type of 10. So R stores rather numbers in a double format. So how do you distinguish between a double and an integer? So integer, you introduce a capital letter L immediately after that number. For example, here I'm saying 10, then I introduce a capital L. So this one is an integer. This one is an integer. So here I'm asking, what is the type of 10? 10. It is an integer. So that is basically the difference between an integer and double. And R has functions for conversion between an integer and double. So we'll be using as.integer and as.double for conversion. For example, here I'm creating an integer called int1, and then this int1 is 10. So let's run this. I'm asking, what is the type of int1? The type of int1 should be an integer. It is an integer. So what if I want to convert this integer into double? So I'll use this function called as.double. So here I'm saying as.double. So I'm telling R, convert this into 1 into double and give me its type. This is how you interpret basically functions in R. So you read it from inside out. So I'm asking R, convert this into 1 into a double and give me its type. Let's run that. It is a double. So I can as well create a double, or I can assign this to a value, maybe a value k. The value k is that, and I run. Then I ask, what is the type of k? Type of k. The type of k. The type of k. Type of k. Type of k is giving me a value of a character, and that's not the case here. That's not the case here. So let me remove this. Okay. As dot double. Okay. As dot double. Yes, as dot double. Yes, should be like this. Then what's the type of k? Type of k. Run this. Gives me it is a double. So basically we'll use as.integer and as.double to convert between integers and doubles. Another data type that we're going to tackle is a character. So character is a data type that's in form of words rather than numerals. So it can either be enclosed in a double or single quote. For example, I'm defining age. Age is 5 years. So I'm saying I'm assigning 5 years to this variable called age. And I run is age. Then I'm assigning the value z to a value 2. So you can either use here in age I've used a double quotes, and here I've used single quotes. So you can't define a variable, for example, a variable maybe x, and then you say you use a 3 3. Then you can't mix that's double quotes and this and single quotes. No, you can't mix double quotes and single quotes. Let's see what's the class or the type of z. Let's run. Now let's run this. Let's run z first. Z. Yeah, there it is. Let's run as the class of z. And there it is. It is a character. So R has a specific package for dealing with characters or strings, so called string R. It's a member. This string R is a member of a core tidyverse package. So there are several functions that can be used for manipulation of strings. So the package string R has a lot of that. Then another data type is complex, and complex data types comprise of a number that have a real part and the imaginary part. So the complex number is in this format: the real part plus the imaginary part. For example, what's the square root of -9? Saying, warning, in square root of -9, NaNs are produced. So we have to introduce the imaginary part so that we can find the square root of -9i. So let's run this. Let's see. There it is. So the square root of -9 is either +2.12132 or -2.1232i. So this i is the imaginary part. So I'm creating another variable called complex, and this complex is -i plus 0, -1 plus 0i. Let's run this. And there it is. So what's the type of complex? 1. It is a complex. So basically we won't be dealing very much about complex numbers. And finally, look at factor. So factor refers, or it's a type of data that is used to refer to qualitative relationships rather than quantitative. So we are referring to quality. For example, gender, race, grades, or grade of a student. So, or types of car models. So those are factors. So we are using I'm creating a factor called factor, and I'm using the function factor, and it can either be good, better, or worse. So these were referring to qualities. Let's run this. There it is, factor. So what's the class of factor? It is a factor. So R also has a specific package for dealing with factors. That package is called factor. I can also check the levels of factor. Factor. Yes, the levels of factor. There it is. The levels are better, good, and fast. So this function called n levels give me the levels that are available in a certain factor. So my factor here that I've created has 3 levels: good, better, and worst. So n levels give you the number of levels. Let's wrap up this tutorial on data types by looking at an example of a data frame in R. So we'll use a library called tidyverse. So if you don't have a tidyverse, you can first of all install the package by install packages, then the name of the package tidyverse. So you have to install the package. Then immediately after installing the package, you have to load the package by running a library, then the name of the package. I've already found the package. Let's run this. It's loading the package tidyverse, and the tidyverse is a collection of packages including the mighty ggplot2, the deployer, the tidy reader, string r, the tables. So let's see. There's a dataset called mpg. So we can as well use the help command, the help function mpg, and here it is. So mpg is available in ggplot2, so it comes with the library ggplot2, or the package ggplot2. So this mpg is a dataset for fuel consumptions of different cars, and it's a data frame with the 234 rows or 234 observations and 11 variables, and these variables are manufacturer, model, displacement, year, CYL, which is the number of cylinders, trans, DRV, which is the type of drivetrain, STY is the city miles per gallon, HWY highway miles per gallon, and fuel is the fuel type, and finally the class, the type of the car. Let's see this dataset mpg. Just run mpg and I run it. It is dataset. So this is how the dataset looks like. So it's a table, and a table it's like it is a data frame. Actually, it's a data frame, and so this table or this data frame has the car manufacturer, the car model, the displacement of that car, the year, the CIL, the trans, the drive terrain. So that is that type of data. So I want us to look at this data type, to this table, or look at this data table and convert into, or we perform basic conversion from one data type to another data type. You can use the head command to see the top. This gives me the top six rows of the variable. So here is manufacturer, model, displacement, years, task. So let's see the structure of mpg. So we run this function str, then the name of the data frame, and here we are, and here we are. So it has given me the structure of mpg, and it has told me that the manufacturer is a character, the model is a character, displacement is a number, year is an integer. So this one we should convert into a date using as.date for command. Here is CYL saying it's an integer, but it has 4, 4, 6, 4, 6. So trans is a character, integer, character, and character. So how do you know if something is a character or is an integer? How do you know? So for example, here I'm using a unique command. There's a function called unique. So unique functions give me the unique number, so the unique variables available in a column. For example, in this column called COL in our data frame mpg, I want to know the unique variable, or the unique variables in that column. So I'm using unique command, and then I'm writing mpg, the name of the data frame, and then I use a $sign. So this $sign allow us to select a certain column or a specific column in a data frame. For example, if I want the model name, I'll just write mpg, or let's run this mpg, then $cyl, c mpg cyl, and here we are. So this one, it has given me the available cylinders. So the first cylinder is 4, the second is 4, then finally the last one is 6. So this cyl, let's see the unique variables, or the unique numbers that are available in this column. Let's run this and see. And here it's either 4, 6, 8, or 5. So this one automatically is a factor. So how do you convert this one into a factor? First thing you write is the name of the data frame, mpg, then $sign, mpg, then $sign, then mpg and cyl, then I assign it as dot factor, then mpg, then $sign again, cyl. So what am I doing here? I'm telling R, change mpg, the cyl column, change this column called cyl in the mpg data frame into a factor, and replace it into the mpg and cyl. Let's run this, and here it is. So if I run the structure of mpg again, this cyl should be a factor. Let's run that. And here we go. Cyl is a factor with 4 levels. So this value, let's change another value here. Let's see, it's a numeric, it's an integer. I want us to change this hwi into a double. So what I'll do, the name of the data frame, mpg, and $sign, let's see, that's hwi, then as dot double, then mpg again, mpg, then $sign wi, then run that, then I run the structure again. So here again, I'm telling R, convert this hwi column into a double and cram it back into mpg $sign hwi, or into hwi column. Let's run the structure again. Here it is. This one should be numeric, and as I've told you earlier, numeric variables are naturally doubles. So this is basically how you convert from one different data type to another different data type. So basically today we have looked at various different types of data types. We have looked at logical, numeric, character, complex, and vector. And we have looked at unique function. We have looked at the type of function and the class of function to check the class or the types of data type. So basically this is a basic of data types. So enjoy learning. Let's meet in the next class. Thank you.